Okay, so we are back. Let's get into solving these two equations simultaneously, right? Okay, so I've left the picture there for us. So again, we are finding the x value and the y value where these two functions meet. These two graphs up here, this one, that's a function, this one, that's a function. So both of them are graphs, and we are trying to find out where they share x value, where they share y value. That's what we're doing when we're solving simultaneously. All right, so let's give ourselves some steps. Step one is to make x or y the subject of your formula. Right, so what it means when something's the subject, it means that that thing is alone on one side, equal to anything else. So if we look at the first equation that we have over here, let's highlight this for us quickly. So if we look at this first one, we want to make either x or we want to make y alone on one side. So if I look at that, I think it will be easier to get y alone. So I'm going to take this 3 positive 3x and I'm going to take it over to my right hand side. So once I do that, I end up with a new equation, and that's going to look like this. Y is equal to the 2 that we have there, and then the minus 3x, because we subtracted 3x on both sides. So this over here gives me a new equation, and this equation is equation number 3. Okay, so we've got this new equation. His name is equation number 3. So our step one was to make x or y the subject. We've chosen to make y the subject, and we used our first equation. The second step, all right? So step two, we are going to put the new equation that we made. So we're going to put number 3, and we're going to put that into the equation that we haven't used, okay? So we are going to, let's maybe make this one orange. We're going to put equation 3 into that orange one over there. We can't put equation 3 into equation 1. The reason we can't put equation 3 into equation 1 is because we used equation 1 to make equation 3. So equation 1 and equation 3, they are the same function. They're the same graph, right? So if we look at the pictures that we drew here at the bottom, if we went to go draw equation number 1 and equation number 3, it would fall on the same line, okay? So you need to put your new equation, which is number 3, into the one that you did not use yet. So that is going to be equation 2. Okay, so we're going to put 3, that's a 3. We're going to put 3 into 2. Okay, so the equation that you made, your new one, you're putting it into the one that you didn't use. So how do you put it in, right? So I'm going to rewrite this equation over here. I'm going to rewrite this. There's a 6, I put a 6 here. There's a x, I put a x. There's a minus, I put a minus. And there's a y. So I'm going to just open my bracket and close my bracket. And I'm going to put that y in a little bit later. But the y goes there. And then there's a equal. And there's a 25. Okay. So I've written down this equation that's over here. I've written it down over here. Okay, the 6x, that's there, the minus, that's there. Now the y, instead of writing y, we found this equation over here, or we've made this equation, equation number 3, and we are going to substitute equation 3 into equation 2. So that means this, instead of y, we are going to put all of this here, because this is equated to y, that's equal to y. So we're going to take that and we're going to go put it in place of y. So now we're going to have a 2 minus 3x. Instead of writing the y, that's what we've got. So if we look at the equation that we have now we have 6x minus 2 minus, well, 2 minus 3x in brackets equals to 25. And when we look at that, and when we look at what we started with, we've created an equation that only has one variable. And if there's an equation with one variable, that means we can solve that variable. So now we can go ahead and solve for x. So let's do the algebra so that we can actually get the value for x. So this negative is going to multiply in. So we'll have 6x minus 2. The minus and the minus multiply. So we have a plus 3x. And it is equated to 25. Okay, let's clear this for us. Right, so now we have x to the power of 1, right? And we remember, whenever there's x to the power of 1, then you want all your x's to the one side and all your constants, the numbers, to the other side. Okay, so we can see that we can see this one over here and this one over here. They are like terms, they are our x terms, so we'll add them. We add like terms by adding their coefficients. So it's 6 plus 3, that's going to give us a 9x. Okay, equals, we have the 25 on our right hand side, but now this other constant, the minus 2, we'll take it to that side, or in fact we are going to add 2 on both sides, so we know it becomes plus 2. So on our left hand side we have 9x, right hand side we have 27. So now we need to get rid of our 9, that is the coefficient of x, so we're going to divide by 9 on both sides to get rid of those. They cancel, so we are left with x equals to 20, x equals to 3. 27 divided by 9 is 3. Okay, so we had that graph up there a moment ago. I've erased it, but that tells me the point where my two graphs meet will be x equals 3. So both graphs are gonna meet. So okay, let's just draw a rough sketch quickly. We had something that looked like that, right? So this x value where they both meet is equal to 3. That's what that means. Okay, so we still need to find the corresponding y value for where they both meet. So what we're going to do is this x value that we found now, we're going to substitute it. So we're going to go take that one back and we're going to go put it into one of our equations. So we have equation 1, 2, and 3. And because, right, we said equation 1 and 3 is the same equation. So if I put it into 1 or if I put it into 3, I'm doing the same thing. Okay, so I can choose to put it into 1 or I can choose to put it into 3. I could also put it into number 2 because equation 1 and equation 2 at our point of intersection, they share the same y and they share the same x. So I can go put my 3 that we found now into 1, 2, or 3. I'm going to choose number 3 because I think it's the simplest because y is already alone on one side. So I'm going to take y equals 2 minus 3x. Y equals 2 minus 3x, but now instead of x we're substituting, so we are going to go put that value we found for x, and we found 3, so we're going to put that in there. All right, so we'll evaluate this. 2 minus 3 times 3 is 9. 2 minus 9 is minus 7. So okay, obviously our picture is incorrectly drawn, but that's not the point. The point is this y value where the two functions we meet would be negative 7. Okay, so we have simultaneously solved our two equations. Okay, just to recap very quickly. Step 1, we make x or we make y, you pick one, the subject of the formula. So that means you get x or y alone on one side, and that's what we did over there. We got y alone on that side. Step number 2, right? We take the new equation that we have, so this equation number 3, that one, and you go put it into the equation that you didn't use. So for us it was equation number 2. So we went to equation number 2, and instead of writing the y, we put the y that we found. Right, so step number 2, new equation into the one that you didn't use. Step number 3, I guess we didn't say what step number 3 was, but step number 3 was you found this equation and you solved for x. You solved for the missing variable. And step number 4 was we substituted our missing variable, the variable that we found, that was the 3, into either one of our equations, number 1, 2, or number 3, in order to solve for y. And that is a quick simultaneous equation.